Okie dokie. Here we go. So we'll get into some chapter 2 stuff today, where we actually do some geometry. Not that the stuff that we had earlier wasn't important, but we always like the geometry better. So in this chapter, we're going to be doing a ton of algebra. We're also going to be doing a lot of work with lines. And we're going to take some lines and put them all over the place. And because of that, we're going to generate a whole bunch of new angles too. So at this point, we have, I think, 5 pairs of angles, right? Simon, what are the 5 pairs of angles we've talked about?
Obtuse.
No, those are types of angles. Let's go there. What are the types of angles, Simon?
Obtuse,
right, straight,
and acute.
and acute. Well done. Now, what are the 5 pairs of angles?
Linear.
Linear is one.
Complementary.
Complementary.
Supplementary.
Supplementary.
Adjacent.
Adjacent.
And I don't know what else.
Vertical.
Vertical. Okay, good. We're going to get a whole bunch more pairs of angles in this chapter. I don't think we'll get to it today. So let's start with a pretty straightforward question, and that is, or not even a question, just a statement. If you have 2 lines, there are 3 ways that those lines can interact. What are they? In other words, draw 2 lines on your paper. On your paper, there's only 2 possibilities. What are they?
Parallel and adjacent. Or parallel and I don't know.
And that, right?
Yeah.
Which is
Intersect.
beautiful. Parallel and intersecting. So that gets us a new term. So we've got, first of all, intersecting, okay, which is what happens. 2 lines intersect. They have a point in common. Then this new term, parallel. So we have a symbol for that. That's 2 little dashed lines because we're lazy again, because we're mathematicians. We don't like to write out that big scary word. So we just create a symbol for that. So they're 2 coplanar lines that never intersect. Okay. So Jalen, give me an example of some parallel lines in the real world. Maybe in this classroom, maybe anywhere that you can think of.
Train tracks.
Train tracks, perfect. Train tracks must be parallel. If they're not, then you get a big mess on your hands. Any others?
Like streets.
Streets, okay, some streets are parallel, like especially if you go into the city, everything's on a grid. Out here, not so much, because you got like weird things like Rand Road that runs through at a diagonal. Okay. Never intersecting. And remember, they're lines, they go on forever. So even if you draw 2 lines that don't intersect on your paper, you got to think about the fact that they're going to extend out forever and might eventually intersect. Then the one that I wouldn't expect you to know is if we come out of the 2 dimensions, you could have something called skew lines, which are non-coplanar lines. This is a visual look up here. Skew lines would be something like this. Okay, they're not in the same plane, however, they'll never intersect, but they're also not parallel. That's it. No other possibilities. They have to intersect, they have to be parallel, or they have to be skew. We won't deal a lot with skew lines because that's 3D stuff, and we don't really get to 3D till later on. So which lines in that picture are parallel, Bree? Little practice naming lines.
E, G, and K, H.
Say again, I'm sorry.
E, G, and K, H.
Elephant, gopher, and kangaroo, hippopotamus?
Yeah.
Good. Does everybody agree? Yes, good. I see a lot of shaking hands. In fact, I agree so much that I put these little extra arrowheads on here. So that's how you show that 2 lines are parallel in a picture. You put an extra set of arrowheads somewhere in the middle. Okay? That's what that says. Bree, which lines intersect?
One of them is, E, G, and
Elephant, gopher, and
F, G.
frog, giraffe. Right?
Yeah.
And they intersect at the point giraffe. Good. And how about 2 skew lines in that picture, Bree?
K, H, and
Kangaroo, hippopotamus.
Yeah, and GJ.
And giraffe,
Jaguar.
jaguar, thank you. Now it looks like they intersect, right? What about that point right there? But they're not, so hopefully you're seeing the 3D thing that the line is going through. That dash line is hidden behind and they don't actually intersect. Okay, so there's a nice illustration of all three. Nice job, thank you very much. Parallel, intersecting, skew. Example 2, now we'll look at some 3D stuff going on there. What's that thing called, by the way? What's that?
Triangular prism.
Nope. Not a bad guess, though. Anybody else? Colin,
Pyramid?
kind of pyramid.
No idea.
Charlie?
Hexagonal.
Nope. Good guess, though. Machek?
Pentapyramid?
Close enough. Pentagonal pyramid because the base is a pentagon. But again, second semester stuff. Now you can see what's going on here. I've got a whole bunch of lines. 1, 2, 3, 4, 5, 6 lines, all going up to meet at G. So I got a whole bunch of points or lines intersecting. I've got some skew lines. Well, where's the skew line? Gopher donkey would be skew to aardvark badger. Okay, so again, you got to wrap your mind around that 3D thing going on. What about parallel lines?
There are none.
There are none, correct. Okay. What about planes now? Well, how many planes are in this picture? First of all, there are 6 of them. The bottom and then the 5 sides. None of the planes are parallel. All of them intersect. Oh, it's not real exciting there. Now, another new term. It's called a transversal. A transversal is a line that intersects 2 other lines. And as it says up there, when that happens, now I'm not saying the lines are parallel, I'm just taking 2 lines, the black ones in that picture, and I'm saying I'm going to intersect those 2 lines with another line. This one is the red one. That red line is called a transversal. And it generates 8 different angles, which I've labeled in the picture. So you probably want to write all of those down because we're going to refer to all 8 of those angles. And we're going to pick different angles around the points of intersection. Okay, so let's establish the ground rules. There are 2 different points of intersection in that picture. One point of intersection is what's generating angles 1, 2, 3, and 4. And for those of you that are visual learners, it's this point up here. There is also another point of intersection down here that generates the angles 5 through 7. When we pick pairs of angles, we need to pick an angle from the first point of intersection and then another angle from the second point of intersection. We don't want to pick 2 points or 2 angles around the same point of intersection because we've already done those angles. You with me? What kind of angles are 1 and 2, Matt?
There's supplementary.
And?
And complementary.
No, can't be both.
No.
Supplementary.
And,
Anybody? Linear, pair, and adjacent. Okay, what about angles 1 and 4, Matt?
1 and 4, those are complementary.
No,
No, supplementary.
no,
Adjacent.
no.
Uh,
You got 2 left.
Vertical.
Vertical, there you go. I know you'd get there eventually. Okay, so that's not very exciting if we pick 2 points around, or 2 angles around the same point. We want 1 from up here and 1 from down there. You with me? Okay, first pair. Corresponding angles. Okay, we will abbreviate those as COR angles, or sometimes we'll just write CA. Corresponding angles are angles from each point of intersection that are in the same location. So notice the mooing cows are in the upper left up here and the upper left up here. Those are corresponding angles. Upper right, in fact I think I listed them here. Yeah, there's all the others. 2 and 6, 4 and 8, 3 and 7. When you're learning these angles, don't learn them by the angle measures or by the angle numbers because we're going to change those angle numbers later on. Learn them by the definition. I just numbered them to make your life a little bit easier. Okay, so angles in the same location around their point of intersection. Upper left, upper right, lower left, and lower right. And I just happen to highlight the upper left ones with a mooing cow. But it's a mute mooing cow because you can't hear it. Okay? 6 pairs of angles we're up to now. Here comes number 7. Alternate interior angles. Okay, now, let's make our lives a little bit easier. I'm going to go back a slide for a second. Corresponding angles. They're called corresponding angles because they're in the same corresponding location around the points of intersection. Alternate interior angles. Again, let's look at the name. Alternate means on opposite sides. Interior means inside. So alternate interior angles are angles on the opposite sides of the transversal in between the intersecting lines. So the top hat star there is in one location. The other location would be 4 and 5. Only 2 pairs of AIA angles. Okay, 7 pairs so far. Am I losing anybody? Am I going too fast? Are we good? Yes or no?
Yes.
Thank you. That's 1 yes. That's enough for me to move on. If my clicker would work. Alternate exterior angles. So again, looking at the name, alternate, opposite sides of the transversal, exterior on the outside. So the incredibly creepy unicorn that it's hard to see there, but he turns and looks at you and smiles. Is 1 pair of alternate exterior angles. The other pair would then be 2 and 7. What do we have, 8 now? That's 8. 9. Am I going too fast or are we good? Everybody up with me?
Yes.
Consecutive interior angles. Consecutive, next one to follow. Interior, inside. These are sometimes, now I learned these originally as same side interior, so I sometimes will refer to them that way. But the big bulgy-eyed fish are consecutive interior angles on the same side of the transversal in the interior. The other pair would be 4 and 6. Okay, so notice the corresponding angles, there were 4 pairs. Everything else so far has been only 2 pairs. Oops, I forgot one. Which one did I forget? Caroline.
Consecutive exterior.
Beautiful. CEA, consecutive exterior. Caroline, which ones would be consecutive exterior?
Would it be like 1 and 7 and 2 and 8?
Perfect. 1 and 7, 2 and 8 are consecutive exterior. Same side of the transversal on the outside. I don't know why I forgot it other than I maybe didn't have any more creepy pictures. Okay, so as I said, don't learn them by the numbers because I'm going to lose the numbers. Same picture, different labeling. So I just labeled the number or the angles by letters. In fact, I chose the letters mouse jaw. And so the question is up there, which ones are first on our agenda here? It's melons in the way. There we go. Which ones are the corresponding angles? Franny.
O and J and M and E.
And? That's 2. You need 4.
And then S and W and U and A.
I didn't hear that. What did you say?
S and W and U
Snake
and A.
and wombat?
And U and A.
Unicorn.
Thank you. Unicorn and aardvark. Okay, well done. Let's give it up, Frank. Nice job. Okay, and how about the alternate interior angles? Joanna? Well done, golf clap. Thank you. And how about the alternate exterior angles, Matt?
O and W, M and A.
Excellent, give it up for Matt. Such enthusiasm. Where are the consecutive interior angles? No, we heard from you, Matt. Mache.
S and E, U and J.
S and E, U and J. Good. And then the other one I forgot was the CEA. Where are the CEAs, Turner?
M and W and O and A.
Well done. Sorry, golf clap for. And we don't want to Mache. I think everybody's happy. Great. Let's move on. Okay. We're done. Got it? Now, one important thing to stress is I made no statements as to how big those angles are. We just identified them by names, that's it. Okay, don't start associating angle measures with those yet, because we gotta change some things before we start comparing angle measures. Questions, concerns, anything for the good of the cause? Good, let me unlock day 2, day 3. Day 3?